Okay. In this video, we're going to be covering the 7.3 worksheet. Topic 1 says plotting the complex numbers. I have two complex numbers. I labeled this one A and this one B, and then I put them in coordinate points. So 8, negative I, same thing as negative 1, use the coefficient. B is negative 6 for your real number, and positive 3 for your imaginary number. Then I went ahead and plot them from the origin. I go forward 8, down 1, that's point A. And B, I went back 6 and then up 3 and labeled that point B. Okay. Number 2 says to write the complex number in standard form. All I basically did here was evaluated what cosine 4 pi over 3 is. So if you go to your unit circle, you're going to go straight to 4 pi over 3, and you have your cosine, which is your negative 1/2, which I put here, and then you have your sine, which is negative square root of 3 over 2, which I have here. Don't forget to follow it by an I. There's your I here because this is your imaginary number part. And then go ahead and distribute the 6, and half of 6 is 3, and then the same thing here. Okay. Part B, we're doing exactly the same thing. Here's your R, and then evaluate cosine 135 on your unit circle. 135 on your unit circle is going to be negative square root of 2 over 2 and positive square root of 2 over 2. So I have those two values here and here. Don't forget to follow it by an I, and then distribute the 3 inside the parentheses, and then you get this answer. For number 3, says write the complex number in trig form. We're using special angles. The first thing I did here was to go ahead and graph this. It's negative 5, positive 5, so I went back 5 and up 5. Labeled my points. Now I want to solve for R. Use Pythagoras identity. 5 squared plus negative 5 squared, that's 25 plus 25, which is 50. And then I went ahead and broke the 50 up into 25 times 2. So square root of 25 is 5. Square root of 2 stays 2. So I found my R. The next thing you're going to do is find your theta. But remember, theta needs to be on the outside, not your reference angle. So I did tangent opposite over adjacent. So I ended up with negative 1. Use your unit circle when you're in quadrant 2. And you will find tangent is negative 1 at 3 pi over 4. Okay, so when we're writing this in polar form, you're using R, CIS, and then use your theta. Same thing for number B. This is going to be in quadrant 1 because you have positive 3, then you're going up 3 square root of 3. So the first thing I did was find R. Okay, so 3 squared plus all of this squared ended up being 36. Okay, square root of 36 is 6. Found tangent, opposite over adjacent. The 3's cancel out, so I'm left with just the square root of 3, which I have here. Okay, using quadrant 1, I went to the unit circle and found where tangent of theta is equal to the square root of 3. Which is going to be pi over 3, which I have here. Then you put it in polar form and you get 6 CIS pi over 3. Okay, for number 4, it's a little different because now we don't have special angles. We're going to have to use something that's not on the unit circle, so we're going to go ahead and find our decimal answers. Do the same thing as we've done before. Go ahead and plot this in the correct quadrant. Positive, negative means we're in quadrant 4, so positive 5, negative 6, and then you're going to find R. R will be 5 squared plus negative 6 squared, square root of 61. Use the approximation by just plugging that into your calculator. In order to find theta, remember you have to use tangent theta is equal to negative 6 divided by 5, so there's my ratio, and then bring tangent over to the other side. Okay. If you remember, when you get your answer to tangent, even though it's in quadrant 4, you have to remember that that's going to be within the restrictions of negative pi over 2 to pi over 2. So we add 2 pi because we want is a standard angle. Okay, so here's our standard angle, and then you can go ahead and round to the nearest hundredths And here I have R, which is 7.81, CIS, and then 5.41. Part B, we're doing the exact same thing. I have -6, -6, -1, -1. Okay. Then I'm going to go ahead and find R. So -6 squared plus -1 squared is the square root of 37. Then I found the decimal approximation. Okay. Tangent is going to be opposite over adjacent. So it's going to be positive 1/6. The negatives cancel out. So I can do the inverse tangent of 1/6. That will give me this angle here. Now remember, this angle right here is in quadrant 1. So in order for me to find an angle in quadrant 3, all I'm doing is adding 1 whole pi. Okay, so if you add 2 pi, you're going to be ended up in quadrant 1 and not in quadrant 3. So be careful with that one. And then I found the theta in decimal form and then plug it into our formula. 6.8, that's R, CIS theta, which is 3.31. For number 5, we're multiplying and dividing the complex numbers. Remember, those formulas are located here and here. Okay, so all you're doing is plugging it in. If you're multiplying, you're adding your thetas. If you're dividing, you're subtracting your thetas. Okay, so let's go ahead and do that. Here we're asked to multiply, so I'm going to look at R1, which is 2, and R2, which is 4, and I'm going to multiply that. 2 times 4, that's going to be 8. Then your CIS, and we're going to be adding our 2 angles together. All I did here was plug this into the calculator and then change it back to a fraction. For part B, we're dividing. So Z1 is at the top, so you're going to use the R1 at the top. So that's 2 divided by 4, CIS, and then subtract your thetas. Always do the first one on top is going to be your first theta minus your second theta. So I plug that into the calculator. Simplify your 2/4 to 1/2, CIS, and then just plug this into the calculator and you should get that answer. Number 6, first thing we're going to do is use our formula, which is located right here. Okay. And I'm going to label everything. So this is my R, this is my theta, and my n is going to be 4 because that's the exponent right here. Okay. Just plug it in. R to nth power, so 6 to the 4th power, evaluate that in the calculator, CIS, n times theta, so 4 times theta, and then 4 times 3 is 12, pi over 5. Okay, number 2 is similar. We are using degrees this time instead of radians. So we have an R of 2, a theta of 10, and an n of 7. So just plug it in. R to the nth power, evaluate in the calculator, CIS, n times theta, 70 degrees. Leave it in this form. Right? Number 7, we're using the same formula, but this time it says to write the answer in standard form. So standard form is going to be like your A plus BI form. Also, another difference, we're not given a polar form, but we're given a complex number here. So we need to find R and we need to find theta. You can draw the picture if that's helpful. I didn't in this case, but I went ahead and know that this complex number will be drawn in quadrant 1. So A squared plus B squared, 32. Simplify the 32. Remember, 32 is 16 times 2. I'm going to do that over here. Square root of 32. That's the same thing as 16 times 2, and I can square root each one individually. So I get 4 square root of 2. Okay. Tangent. Remember, since we're in quadrant 1, this is going to be 4 and this will be 4. You can see that tangent theta, this is my theta, is opposite over adjacent, so tangent theta is going to be equal to 1. And then use your unit circle to determine that tangent of theta is equal to 1 at pi over 4. So I have that here. Okay. Now that I have that, I have my R, I have my theta, and my n is going to be this 5. So I can use the formula just to plug everything in. Again, that formula is located right here. R to the nth, CIS, and theta. Okay. r to the nth, r to the nth, CIS, n, which is 5, times theta, which is pi over 4. Plug that into the calculator, and then you will get this answer. Now this might be a little bit difficult, so I'm going to go ahead and do this for you. Okay? First thing I'm going to do is go ahead and do 4 to the 5th power. Okay? In my calculator, 4 raised to the 5th is equal to 1024. That's where I got this number from. Okay. Now I'm going to do this one. This one's a little bit different because you're not going to be able to do this in the calculator. But remember what this says. This is going to be the square root of 2 times itself 5 times. Let me go ahead and do that one up here. So square root of 2 times 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 square root of 2. Okay, so here we have 5 of them. Square root of 2 times the square root of 2 is just 2. Square root of 2 times the square root of 2 is another 2. This one is going to be left as the square root of 2. So 2 times 2 is 4, square root of 2. That's where I got this part from. Okay, CIS, I just multiplied these two together and I still got that. Then the next thing I'm going to do is use this itself, and then when I distribute it inside, look, you have another square root of 2. So what we're going to do is we're going to say the square root of 2 times the square root of 2. Well, that's just 2, but we're dividing it by 2 as well. So all of this cancels, but I do have the negative out here, so the negative comes out in the front. Okay, and I do that to the second one as well. The negative is there, comes out to the front of the coefficient, and then I'm still left with the 4096. Don't forget to bring down your I. For number 2, the same thing. I went ahead and drew my picture because this is not in quadrant 1. It's going to be in quadrant 4. Positive 5, down 5, square root of 3 here. Go ahead and solve for R. I went ahead and did that here. You can plug this into the calculator. It's going to be 25 times 3, which is 75. Okay, and then 5 squared is 25. So this adds up to 100, and the square root of 100 is 10. So I have my R as 10. Theta is opposite over adjacent, and it comes out to negative square root of 3. Because we're in quadrant 4, we want to go ahead and come over here and say quadrant 4, theta has to be 5 pi over 3, which I have here. Okay, so now I have my R, now I have my theta, I'm going to have my n being the 3. So r to the nth, so 10 to the 3rd, CIS, n, which is 3, times theta, which I have down here. Okay, this evaluates to 1,000, CIS, the 3's cancel, and I have 5 pi. This is not in standard form, so the easiest way to do this is go ahead and subtract 2 pi until you get to a number between 0 and 2. So if I subtract 4 pi, I get 1 pi. And then I can go ahead and say, what is cosine of pi? Use your unit circle. Cosine of pi is going to be negative 1. So there's my negative 1. Sine of pi is going to be 0. So I have 0 here. Then distribute the 1,000 inside, and I get negative 1,000. For number 8, we're finding the nth roots of a number. So here I have a complex number of 16. So in other words, it's x to the 4th is equal to 16. So the first thing I did here was I noticed that r is going to be equal to 16. Remember, anytime it lies on the x-axis or the y-axis, your r equals whatever the coefficient of that complex number is. Because this is positive 16th, our theta in this case will be 0. Okay. The next thing I did was go ahead and use the formula, which you can find right here. Okay, I'm going to be using angles, so I'm using this one. It says the nth root of r. So the n in our case here is 4, so I did the 4th root of r, which is 16. Okay, CIS, and then I used the rest of the formula. Theta, which is 0, plus 360 degrees divided by n, and in this case is 4. Okay, you can evaluate this in the calculator. I'm going to go ahead and do that for you here. I start with the 4, and I go ahead and do second, and then you're going to be using the little caret right here. Okay, so I'm going to do that one. Then I'm going to put in 16, and then you can see that equals to 2. I set k is equal to 0, which means that all of this is equal to 0, so this is 0. Then I went ahead and evaluate. Cosine of 0 is 1. Sine of 0 is 0. Okay, and then I distribute. So I got 2. Second, I did k is equal to 1. This became a 1. And all I'm doing here is 360 degrees divided by 4, which came out to 90 degrees. Then I did cosine of 90, which is 0. Sine of 90, which is positive 1. Don't forget your I. Distribute the 2, and I get 2i. Okay. K is equal to 2. I still get 2 here. This is 360 degrees times 2 divided by 4. That came out to 180. Then evaluate. Cosine of 180 is negative 1. Sine of 180 is 0. And then distribute the 2 into the parentheses, and you should get negative 2. Okay. K is equal to 3. Plug in a 3 here. You should get 270. And then go ahead and do cosine of 270, which is 0. And then sine of 270, which is negative 1. Distribute the 2, and you should get negative 2i. Okay. Remember, for these, you can evaluate 2 of them. We can check 2 raised to the 4th power. That comes out to 16. Then we can do negative 2 raised to the 4th power. That also comes out to 16. These two, remember, you did the 2 raised to the 4th power already, and I to the 4th power is equal to 1. So that will come out to 16. And the same thing occurs here. Negative to the 4th power is a positive. 2 to the 4th is 16. And an I to the 4th is just equal to 1. So this comes out as well. Okay. Number 2, we're doing another one. Now we have x cubed is equal to I. So if I were to graph this, remember it's a positive I. This is your real numbers on your x-axis. Your imaginary axis is the y. And since I is positive, you're basically going up. Okay? So I can say r is equal to whatever the coefficient we have here is, which is 1. And theta, notice where the point is, it's at 90 degrees. And then n is going to be equal to 3. So now we can plug in our formula. The cube root of r, which is 1, CIS, theta, 90 degrees, plus 360k divided by n, which is 3. Then I'm going to go ahead and let my k equal 0. And then I get, this is 0, and then I get 90 degrees divided by 3, which is 30 degrees. Okay. Evaluate cosine of 30, sine of 30, which I have here and here, and then distribute. And I get this answer. Okay. For k is equal to 1, you're going to have a 1 here, and it'll be 360 plus 90, which is 450. 450 divided by 3 is going to be 150. Okay. Cosine of 150 is located here. Sine of 150 is positive 1/2. And then distribute the 1 so you get this answer. Okay. K is equal to 2. You're going to have 1, CIS, 270 degrees once you put in the 2 here and evaluate. And then 270, you have 0 and negative 1. Okay. Distribute, and you get negative I. Okay. Number 9 says we're going to find the roots, but this time it's a little different because it's not on one of the axes. We're going to be looking for r, and we're going to be looking for theta. So let's start with finding r. R is going to be, this point is going to be located in quadrant 3 because you have a negative and a negative. So negative 2, negative 2 square root of 3 going down. Okay. So when I take that and I square it, I get 4. When I take this and I square it, I get 12. Add those together, you get 16, and then the square root of 16 is 4. Okay. N is going to be whatever root you're looking for. In this case, n will be 4. And then I can also find for tangent. Tangent is opposite over adjacent, so the 2's will cancel out, and so will the negatives, and you're left with the square root of 3. Okay. So because we're in quadrant 3, we're going to use our unit circle and find the theta where tangent is equal to the square root of 3 in quadrant 3 at 240 degrees. So theta is going to be equal to 240. Okay. Then we use our formula. It's going to be the fourth root of r, which is 4, CIS theta, which is 240, plus 360k, all divided by n, which is 4. Okay. And then we're going to evaluate this. This is a little harder to see, but I'm going to go ahead and do that for you over here. Now, remember that this is written in radical form, but we can change it to exponential form. Our base is 4, and this is like 4 to the 1 power, and then our exponent would be 1 over 4. So let's try and rewrite this a little bit differently. Now I'm going to say, well, this is still 4. This is going to be 2 squared. This and this are exactly the same. Okay? So if I'm going to write it this way, I'm going to use a base of 2, and our exponent will be 2 fourths. 2 fourths. Isn't this exponent, can't we simplify it? We can say it's 2 to the 1/2. Okay? When I change this back to a radical, I'm going to have the base inside, and then I'm going to have a square root. This is the 1 out here inside the radical. The 2 goes on the outside, but because it is a 2, it's understood. So we don't have to write the 2. So that's how I got the square root of 2 here. Okay? CIS, let k is equal to 0. Substitute the 0, and I got 240 divided by 4, which is 60 degrees. Cosine of 60 degrees is 1/2. Sine of 60 degrees is square root of 3 over 2. And then all I did here was distribute the square root of 2 to inside the parentheses, getting this solution. Okay? When you're multiplying radicals, you can just multiply the inside numbers. Okay? K is equal to 1. You still have the square root of 2. CIS, evaluate this, add these two together, divide by 4, you should get 150. And then evaluate. Cosine of 150 is that, sine of 150 is that, and then distribute the square root of 2 inside the parentheses, and you should get this. Okay? Let k equal to 2. Again, square root of 2, CIS, put a 2 in here, evaluate it, you should get 240, and then do cosine of 240, which will give you this, sine of 240, which should give you that, and then distribute the square root of 2 into the parentheses, and there should be your answer. K is equal to 3, square root of 2, CIS, evaluate by plugging in a 3 there, you should get 330, and then cosine of 330 should be the square root of 3 over 2, and the sine of 330 should be negative 1/2, and then distribute the square root of 2 into the parentheses, and you should get that. Okay? And then here's your final answer. Okay, last problem. Find all complex square roots of this complex number. First thing you're going to do is determine which quadrant it is. So we're going to plot the point, -3, +3, square root of 3. That makes us in quadrant 2. So let's go ahead and find r. -3 squared plus 3 square root of 3 squared comes out to be square root of 36. Square root of 36 is 6. N will be equal to 2. Okay? Then let's find theta. Theta is going to be tangent, opposite, which is 3 square root of 3, divided by adjacent, which is -3. So these cancel, and I'm left with a negative square root of 3. Because we're in quadrant 2, we want to look on our unit circle and determine where tangent is negative square root of 3, and that will be located at 120 degrees right here. Okay, so then I have my theta there. Plug in our number. It's going to be the square root of 6 CIS theta 120 degrees plus 360 degrees times k, all divided by n, which is 2. Okay, square root of 6 can stay like that. CIS, start with k is equal to 0, so you have 120 degrees divided by 2, which is 60. Cosine of 60, 1/2. Sine of 60, square root of 3 over 2, and then distribute the square root of 6 into the parentheses. Okay, you get that answer. You can go ahead and simplify it like this. K is equal to 1. go ahead and plug in a 1 here. Evaluate this angle. You should get 240 degrees. Cosine of 240, negative 1/2. Sine of 240, negative square root of 3 over 2. And then distribute the square root of 6 into the parentheses. All I did here was simplify. Because n is equal to 2, those are your only two solutions. All right, this concludes the 7.3 worksheet. Let me know if you have any questions.